Inverse trig functions. Let me start with very basic ideas you guys already know. Pi equals 180 degrees, so pi is in radian, and the radian measure for pi is approximately 3.14 when you round it to 2 decimal places, or you can write 3.142. Other measures like pi by 2 will be the 90 degree, pi by 3 will be 60, pi by 4 is 45, and pi by 6 is 30, and these angles we call reference angles. Now you know the following results. Sine 0 degree is 0. Sine pi by 3, which is 60 degree, or cosine pi by 6, which is 30 degree, they are also same square root of 3 over 2. Sine pi by 4, cosine pi by 4 is square root of 2 over 2. Sine pi by 6, cosine pi by 3, this is 1 half. If you observe carefully, you will see that pi by 6 and pi by 3, they are complementary, because when you add pi by 6 with pi by 3, your answer is pi by 2. And everywhere it happens. When you see 0 plus pi by 2 is pi by 2. So they are complementary. So in the complementary cases, sine and cosine values are same. So if you know these standard values in the first quadrant known as the reference angles, then from these we can determine the inverse form. So I'm taking an example. You see here, sine pi by 3 is radical 3 over 2. So if you just move sine or take inverse, then you get pi by 3 will be sine inverse square root of 3 over 2. So in this section we will be doing all this stuff, and we have to remember other three things. Let me show you. So following results are important. Sine negative x, where we consider x as positive acute angle, will be negative sine x. Tangent negative x will be negative tangent x. But for cosine negative x will be cosine x. And why these results, you know from all students take calculus. For example, if my x is in the first quadrant, acute angle, then negative x is going in the fourth quadrant. In the fourth quadrant, sine and tangent both negative, that's why you get this. But cosine in the fourth quadrant is positive, that's why this. Now we'll see how this changes in the inverse function. So for sine inverse negative x, we are writing negative sine inverse x. Tan inverse negative x, we are writing negative tan inverse x. And with the domain where our sine function, tan function is 1 to 1, will be negative pi by 2 to pi by 2. But for cosine, you know that the inverse of that function should be valid in the interval 0 to pi. So the graph clearly shows y equals sine x. This is the graph. And we know that negative pi by 2, the value of sine x is negative 1. And at pi by 2, it is 1. So on these, negative pi by 2 to pi by 2, this graph is 1 to 1. So it has inverse. Tangent also, you see, negative pi by 2 to pi by 2. You have a vertical asymptote at those points, and the graph is 1 to 1. So you have inverse. Cosine from 0 to pi is 1 to 1. So that's why the domain for this one will be 0 to pi. We have an example. It says find the exact value of sine inverse square root of 3 over 2 and sine inverse negative square root of 3 over 2 in the interval negative pi by 2 to pi by 2, where the function is 1 to 1. We have already seen in the first quadrant reference angle sine pi by 3, which is 60 degree. Sine 60 is radical 3 over 2. So then immediately you can say pi by 3 is sine inverse radical 3 over 2, and we can confirm this result. It said that you have negative pi by 2 actually here, positive pi by 2 is here. So you are looking for angles in the fourth quadrant and first quadrant, because we are going in the positive direction. So when you have pi by 3, it's 60 degrees, so it's here. So we are done with this. So next we are working on sine inverse negative radical 3 over 2, and we know that sine is odd function, so this negative we can pull outside. So get a negative in here, then you have sine inverse radical 3 over 2. You have negative sign, and then you have seen that sine inverse radical 3 over 2 is pi by 3. So you got here pi by 3. So now pi by 3 is the angle here in this direction. So this is also within this domain. So you are done with this. So let me explain example number 2. In this we are saying find exact value of cosine inverse radical 3 over 2 and cosine inverse negative radical 3 over 2 in the interval 0 to pi. So in this, now if we look at the reference angles, we know cosine pi by 6, which is 30 degrees. So cosine 30 is radical 3 over 2. So then your pi by 6 now will be cosine inverse radical 3 over 2. And then same thing happens here when you have cosine inverse negative. We know that pi minus, we have seen before. So then you just say pi minus cosine inverse, this one is pi by 6. So that one is your 5 pi by 6. Now if you look at the quadrants, now if you look at the quadrants, you will see that you are actually looking for this interval 0 to pi. So your angle starts from 0 and goes up to pi. And in this case, you can see 5 pi by 6 somewhere here. So that supports our conditions. Example 3, we need to find the exact value of tangent cosine inverse x. So I will apply a simple concept from SOHCAHTOA. I'm just taking a right triangle, and since I have cosine inverse x, so I'm assuming like x over 1, and you know that cosine is adjacent over hypotenuse. So adjacent is x, hypotenuse is 1. So definitely this side using Pythagorean you will find 1 minus x squared. So then the equivalent form of this one will be now tan inverse. You can go from here. So tan inverse is opposite over adjacent. So it will be square root of 1 minus x squared over x. Now tangent tan inverse will cancel out. So the answer is 1 minus x squared over x. You are done.